Let's start working it bit by bit. I know these in our problem is equal to 141.4 volts. And I know that my maximum voltage coming out of the power supply is equal to my maximum current coming out of the power supply times my impedance. So that's 141.4 volts is equal to current from the power supply times 43.5 ohms. Something. 3.47.
Okay, I was confused
About 3.249. Right, because it's just the 141.4 divided by 43.5.
Yes.
I got 3.25.
I think I didn't round the like 43.5.
She's a purist.
I'm a purist.
You may interpret that as you are scum because you rounded. I think that is that the subtext?
I mean, yes.
Okay.
It was.
I don't
100%.
like Brooke's answer.
Okay.
I would say
The like difference of like one
it's a big difference.
decimal point.
That could
Not
kill
even.
somebody.
Scum might have been harsh.
A
I
little
think
harsh.
inferior was.
I'll take
Inferior.
scum. I'll take scum.
Inferior.
That's bad too.
I'll take scum on the chin.
I'm just kidding, Harrison. You know it's coming.
Not as
That
good.
was all.
Not as
that
good
was
as
all
better.
Dr. Fox.
No, it's too late.
You should have never taken that picture with him on Fun Friday.
It's too late.
It's all about those points.
All right. So let's come up with our equations here. Well, we have. Let's get rid of something. All right. Our 43.5 we've used. We don't need that anymore. We don't need that. All right. So my voltage from the power supply is equal to my voltage across the resistor, which is equal to the voltage across the capacitor. What is my equation for my voltage?
Voltage for what?
Any of them.
V equals
They're
IR.
parallel. Pardon?
V equals IR.
Now I'm looking for the equation
Is it
for the instantaneous values.
Does it have to do with these guys over here?
The epsilon m sub m cosine this one.
Okay,
Yeah.
yeah, that's the one.
Okay. But you're not writing it down, so I don't know if I'm.
No, I'm looking for numbers. Throw the numbers in.
Okay.
I'm just gonna let you fool yourself and then. say
Okay,
no.
so I'm looking for
Just to clarify while Harrison is
Okay.
thinking,
or,
is the capital V the same as the capital V with the little tail?
The one with a little tail, that's my lowercase.
Okay.
That's how I'm differentiating between upper and lower since
I see, thank you.
they look too similar.
so for the VPS, is that, or, okay, so you're looking for one equation, you're not looking.
Yeah, since they're all the same.
141.4. It's V
Volts.
volts cosine parentheses 377 radians per second T plus 0.
Boom. 3 of them done right there.
See about you that time so you can shine.
Thank you. Except I just recited the equation from the last problem.
Hey, it still applies. All right, current from the power supply. We have all the information we need for that. All the numbers are, well, actually, we're missing a number, but we'll get to that in a moment.
3.249 amps.
Oh, you're gonna use her number?
Oh my god.
No.
I'll be honest,
No,
I
no.
almost just dropped an F-bomb after he said that.
Sorry, I swore in class and I dropped my.
All right, what comes next?
Cosine 377 radians per second T plus, ooh, okay.
Yeah, this is the number we don't have yet.
We don't have this number yet.
So, which number would this be?
The phi, right, between, wait,
Which phi? All right, we have three different angles involved here. We have the initial phase of my power supply, which is 0. We have this angle right here, which is between IC and IPS, and then between IPS and IR. There is an angle here, obviously, but that's just because I drew this up in the first quadrant. I could have drawn my first vector anywhere. Which of these, so hint, it's not that one. Which of these two is the angle that we need to put right there?
I wanna say it's between IR and IPS.
Yeah. Because IPS is our reference here. That's where we've established something. We know that's 0. And so where are we relative to that is the important one. That's this right here.
Wait, I thought we were doing current.
Yeah, this is the current phasor for the power supply, and this is the voltage phasor for the power supply. We're trying to find the difference between them. That was not a satisfying answer for you, I think.
I got it.
Okay,
Is that better? I did actually get it.
good.
Yeah, that sounded condescending.
All right, so what I have here is I've got a right triangle, again, isn't that fortunate? So my hypotenuse is IPS. This is the angle we want right here, which I'm labeling phi 2, or whatever angle you like. This is the IR and IC. So what trig function should I be using here?
Arctan of I sub C over I sub R.
All right, since I don't know IC and IR, let's get it in terms of things I do know. IC is, that's VC over X sub C.
Wait, why is it arctan?
Opposite over adjacent.
Oh, okay, okay.
Is it messing you up that I've drawn the right triangle at an angle?
No, I'm just not good at trig, and yeah, okay, now it makes sense. Yeah, so Katoa, yeah.
Would we make it easier on ourselves if we used a different trig function since we know, the current of the power supply, or should we like only use arctan?
If we're using this right here, since we have the impedance, we could do it that way. I mean,
Yeah, I guess it made sense for me to use that and the resistance since the angle's there, but I don't know why.
Yeah, it was like adjacent hypotenuse.
That's what I was thinking, Brooke.
That'd be
was-
cosine.
Yeah.
well,
But
let me finish writing this
Yeah,
out, and then
yeah.
if you wanted to go the other way, we can do that too, over R. My voltages are the same, that's gonna cancel out, so what we're left with is the arctan of R over XC, which is the arctan of 50 over 88.4.
Did you mean to flip R and XC?
Yeah, that threw me too.
Yeah, all right.
Because-
It's part of the cancellation process, I think.
Oh, yeah, okay, I see,
You good?
yes.
All right. And this ends up being 0.515?
Why the question mark, Dr. Fox?
Because I'm sometimes prone to Carol's errors.
Is it-
0.1515.
Is it gonna be the same as the last problem? Cause that's
Yeah.
what we got last time.
Yeah, it's basically, it's the flip of what we had before.
So that's in radians.
That is in radians. Positive 0.515 or negative 0.515?
Was negative, because we started at IPS and we went this way. So I'm thinking negative.
Since the math people decided that the regular direction of rotation is counterclockwise and our angle is clockwise of IPS, it would be negative, right?
Alright, so you came up with an angle, that both of you, I think, came to the same conclusion,
Conclusion.
Yeah.
because you're going this way?
Yeah.
Why are you going that way?
Didn't we say that the IPS was like the established? You said this was like the established point that we're starting
Right.
at, and we wanna find. I don't know, that's all I got.
Where are you relative to 0?
You're like below it, right? No, wait, which side are we on?
This is the one that we've established is 0.
Right.
So to get from here to where the phaser we're talking about, which way do I rotate?
Oh, positive.
Oh, right.
Is epsilon sub naught where current of the capacitor is? Where is our, wait. No. Is it at, epsilon sub naught is this arrow in our first quadrant, right?
Right.
So to get from the maximum to where it's positive? Oh, to.
Going from here to here.
Right.
Oh, yeah, that's
That makes
positive.
sense.
See, that was my initial thought process, but then you said like, the like established 0 was
Right.
IPS.
The established 0 is epsilon sub,
Okay,
is there.
I think I just,
I misheard in exactly the
Yeah.
same way somehow.
So I apologize if I misspoke.
that's okay.
It's okay.
If it's the fact that you could not read my mind, then as always.
Yeah, my mind
Then
was
just be
going
better.
off this week.
Be better.
That's what we do that.
And then, so we have the maximum, so we have that one now. IR, that's just gonna be VR over R. I know that maximum V is 141.4, resistance is 50, so I have my maximum current for resistance. This would be VC over X sub C, and that's 141.4 over 88.4. Whatever that happens to be. Anyway. The second alarm went off. I have a few things that I forgot to hand back to well, 2 of you that are here.
Oh, I heard I left for the 3 minutes work back and forth.
I hope you have a wonderful afternoon and a wonderful couple days. I need to double check to make sure the lab is posted.